All right, let's jump right in. Today we're doing a deep dive on, well, it's really a solution to a huge architectural problem. We're looking at the PureLink DOF T2.0 TXRX system. It's a 4K 60 DisplayPort and USB fiber extender. So the mission for you listening is to really get a handle on how you distribute the highest quality video and control signals over these just extreme distances. I mean, think about it. You've got uncompressed 4K video. That's a massive, 18 gigabits of data per second.
A huge amount of data.
Exactly.
Yeah.
So how do you push that? We're talking 4K at 60 hertz, 4.4.4 color HDR. How do you send that more than a few hundred feet before it just, falls apart?
And that's the core question, isn't it? The sources are pretty clear on the answer here. This system, it manages to hit a distance of up to 1.24 miles. That's 2,000 meters.
Wow, over a mile.
Over a mile, yeah. And it does that over a single strand of single-mode fiber. And that's not just a nice-to-have. It fundamentally changes how you can design a system. You can physically separate your secure hardware from the control room. That's a massive win for security and operations.
Okay, so let's dig into that. We have the distance, but what about the quality? That's the other half of the equation, isn't it?
Absolutely. We're talking about very high-fidelity video support here. DisplayPort resolutions up to 4K at 60 hertz. With that 4.4.4 HDR.
And that 4.4.4 is the key, right? No compression on the color information.
None whatsoever.
Yeah.
It's non-negotiable for, professional post-production or high-end simulations. And to do that, you just need the full 18 GBps of bandwidth. That's basically the top-end spec for HDMI 2.0.
Yeah.
If you can't support that bandwidth, you start losing color data, and then what's the point of the 4K display in the first place?
And that scale is just staggering. 1.24 miles. The source mentions it uses LC-terminated fiber optic cables to get that lossless transport. But I have to ask, isn't that more complex? I mean, running new fiber versus, say, just using existing Cat6 cable.
It can be, but the payoff is huge.
Yeah.
And it comes down to one critical thing, EMI.
Electromagnetic interference.
Exactly. Noise. If you run a copper cable for that kind of distance, especially through a large building with elevators, power lines, machinery, you're going to pick up so much noise.
The signal would be a mess.
A total mess. But fiber is just light going through glass. It's completely immune. So the signal you put in is the exact signal you get out a mile later. It's really the only way to guarantee that 18 GBP's link holds up.
Okay, so the video is pristine, but it's easy to get tunnel vision on just the picture. What about audio and, control?
Right, and this isn't just a video pipe. It's a full professional system. On the audio side, it's not just your standard LPCM 7.1. It supports the really high-end formats, things like Dolby True HD, Dolby Atmos, DTS HD Master Audio.
BTSX as well, I see here.
BTSX, yeah. And those formats are extremely sensitive to any kind of data loss or compression. Just reinforces why that lossless fiber transport is so essential. You need that purity for the 3D audio to work correctly.
And it's not just about passive consumption, listening and watching. It's about interacting, right? This is a KVM solution.
It's a full KVM, yes. Keyboard, video, and mouse. You get bidirectional IR and RS-232, plus USB support for your keyboard and mouse. So you'll be sitting at a desk over a mile away from a computer that's locked in a secure server room, and it feels like it's right under your desk.
That's a powerful feature. The sources also mentioned something about real-time auto-edited management. That sounds like a convenience feature, but a pretty important one.
Oh, it's huge. Anyone who's set up a complex AV system has run into those handshake issues.
Where the source and the screen just can't agree on what to do.
Exactly. You get black screens, flickering. It's a nightmare. This system just handles that communication automatically, so it works.
And just a quick note for those of you who work in certain sectors, the sources do point out that this system is TAA compliant. That can be a deal breaker for government or federal contracts. So let's bring it all together. What's the main takeaway here? We have this system. It's priced around $2,300. It seems like it's a tool for those environments where you just can't compromise. You need the full 18 GBPs, bandwidth, perfect signal integrity, and complete KVM control all over these truly massive distances.
It's it, exactly. And it raises a bigger question, I think. We're now in an era where absolute lossless quality is becoming mandatory for formats like Dolby Atmos or true 4K HDR. So the final thought for you to kind of chew on is this. If fiber is the only way to really guarantee that quality and future-proof an installation, how does that change the decision-making process when you're planning a big AV project where maybe copper has always been the easier or the cheaper default choice?